Because I don't want to just broadcast the answers to the internet. That's why.
I mean, you do say a lot of important stuff at the very beginning, so that it gets missed.
Sometimes. Yeah, usually it's like housekeeping stuff. Could you please clear the stuff off your desk there?
Yeah.
We got Iowa through at 49 because I didn't think that I would be here.
Okay. Well, if you want credit for it, show it to me.
But like, I heard the guy was here.
Oh.
Wait.
Okay. Are there any problems you want to go over from problem set 51? So I have your textbooks open to page 210. Page 210, please. You have those problems in front of you. Opening it up. Any problems from last night's homework? 51 that you want to go over. Now, lesson 51 is the last lesson that's going to be on the midterm. Reminder for midterms next week. It's just, so Monday, no school. Tuesday, Wednesday, Thursday, midterms. Friday, again, no school for you guys.
Whoa.
What is the midterm in your class?
For the midterms, there will be 2 a day. One will start at 8:40, and the other starts at, 10:30. You'll have an hour and a half for each midterm. You have to stay, for the first exam, you have to stay through because of COVID restrictions until the time is over. For the second exam, after an hour, you'll be able to leave. If you don't have a second exam that day, then you can leave after the first one. You do need to be in dress code. Please be in dress code for exams. The schedule has been sent out, which days or which exams.
Do by period time?
Yes, so it'll be by period time. So let me actually pull that up so I can tell you guys what.
Tuesday we'll have.
Are we all taking the same exam? Like, are we all going to get the same class?
What do you mean?
Like, it's not like.
Are they gonna be combined?
So you guys, no, we're not going to be combining any classes this year because of the COVID restrictions. So you'll be taking the midterm in here with me, just us, when you take that. We're going by
They'll be
period.
taking different midterms than us.
What?
They're different classes. So are they gonna take like different tests while we take different tests?
No.
Like, whatever.
You guys are all going to.
Finish the test in a row.
We're gonna take the same test in different classes.
Oh, that's right, that's what I was saying.
So you're going to take. Now, where is the email about this? Because I want emails to me.
They have a different, they're in a different class.
Did anybody?
Midterm exam information. All right, so listen. On Tuesday, 8:45, first exam is this one. You'll be in here. That's your period 1 exam. The second exam that day is whatever you have 4th period.
Oh, scripture.
So midterms, I'll write it up over here. Midterms.
Scripture midterm.
I'm feeling that.
Okay, Tuesday, Wednesday, Thursday. Tuesday, you have 1 and 4. Wednesday, first exam is for 6th period. Second exam is for 3rd period. Thursday, first exam is for 2nd period, and last exam is for 5th period.
That's so.
All right, that's how it's going to work this year because of the COVID restrictions. So you'll take them with your normal class in your normal classrooms.
I'm probably gonna do best on it.
All right. So this is the very first midterm here.
The hardest day is
This lesson here, 51, that I'm opening it up for questions about. This is the last lesson that's going to be on this test. So any questions from the homework that you want to go over from pages 209 through 211?
You do, that's 19.
Number 19, yes, number 19 is based on lesson 49. So this is one of the lessons that I wasn't here for. Number 19, they want you to multiply together. I'm sorry?
I don't think they explained this one.
Yes, they did in lesson 49.
No, I mean like, the substitute. Can they explain how to do it?
Okay. What's your point?
Yeah.
So 2x plus 4 and 5x minus 3, we're multiplying together. If you look at lesson 49, what they'll tell you about this, it will also take a minute to go over those lessons that were done while I was out. When you're multiplying together polynomials like this, notice the two things here, 2x plus 4 and 5x minus 3, each of those is made up of 2 terms. Yes, this one's made up of 2x and 4, the combined with addition. This one's made up of 5x and negative 3. When we multiply together polynomials, we have to use the distributive property so that every possible combination of things between the two get multiplied together. So the easy way to remember this is to use the word FOIL, first, outer, inner, last. So first we're going to multiply together the first two. So 2x and 5x. What do we get when we multiply together 2x and 5x?
10x squared.
10x squared, yes. Notice that the 2 and the 5 multiply to give us 10, and the x multiply to give us x squared. 10x squared. Now outer. So we're going to take the outer ones, 2x, and what is this here? Negative 3. What's 2x times negative 3? Negative 6. Negative 6x. All right, now inner, the 2 in the middle, we've got 4 and 5x. What do they multiply to give us?
28.
And then last, the last ones of each. Negative 12. 4 and negative 3 gives us negative 12. Now, are we done?
I like her.
We should combine like terms. What like terms do we have here?
6x and 20x.
Not 6x.
Negative 6x.
Negative 6x and 20x. So when we combine those together, what are we going to get?
14x.
Yes, plus 14x minus 12.
What?
10x squared minus 6x and plus 20x. Those combined, they're like terms.
Okay.
And so they give us 14x.
Alright.
And then minus 12. Yes?
Yeah.
Okay. Notice also, when we're writing answers like this, notice that our answer is also a polynomial. It's made of 2 or more algebraic terms being added together. Notice the order that I've written these in. Usually if you do FOIL correctly, you'll automatically have this. But notice that I've got x squared, then x or x to the first, and then x to the 0 or 1. What do we call that? X squared, x to the first, x to the 0. Descending order of the variable, and we're supposed to have that.
That could be like.
What that's
Like,
called?
do you have like questions that are like words?
No, probably not. Not many. But this is something that you should know to do. If you gave me, for example, 14x plus 10x squared minus 12, I'd take off 1, like if you didn't simplify. It should be in descending order of the variable.
No corrections,
No, there won't be corrections for midterm.
right?
There won't be corrections for the
No.
Wait, what did you just say about you'll take points off?
If you wrote this, 14x plus 10x squared minus 12. These two are equal to each other,
But it's not descending order.
but you should be giving the answer in descending order of the variable.
I don't get that.
Not just
X squared, x to the first, x to the 0.
Oh.
Notice how the exponent is going down?
Yeah.
Because we have the highest exponent first and then it decreases. Here, that's not the case because we have x to the first, then x squared, then x to the 0.
So if it said put the exponent increasing, it would be negative 12.
No, it's not going to ask you to do that. But if it did, yeah, it would be negative 12 plus 14x plus 10x squared. But it won't ask you to do that. I'll only ever ask you, and I'll always ask you, to put them in descending order of the variable.
Alright.
Okay? Yeah, don't worry about doing it the other order.
Can you also do 20? Because 20 is kind of like I just had. Like,
Yes, 20 is the same kind of thing. Let's do that one also. X plus 3 squared. Let's do right here. 20 is x plus 3 squared. What do we have to do here?
What's the exponent in?
Yeah.
Be careful. What does this mean? X plus 3 in parentheses squared.
It means 3 plus
Or like
x.
everything.
And then no, actually you do the
What does it mean to square something?
multiply by itself.
To multiply it by itself. What are we multiplying by itself here?
X and
X and 3.
No.
X and x plus 3.
We're multiplying x plus 3 by itself. Notice it's in parentheses.
You lost me. Oh, I know.
This thing here,
Is being
where's my red marker?
The whole thing is being
The whole thing is being squared because these parentheses are there. X plus 3. This whole thing is being squared. So when we square it, when we take 2 copies of it and multiply them together, that's what it is that we're writing 2 copies of. We've got x plus 3, and then we've got x plus 3 again.
Oh,
Yes?
Oh.
Yes?
yeah.
X plus 3 squared, if that's in parentheses, whatever's inside the parentheses, that's what we're squaring. So we've got x plus 3 twice. Now once we get to this point, what do we do to get rid of these parentheses?
Outside, inside,
X
left.
times
First, outer, inner, less. We do, yes.
X times X.
Which gives us,
X squared.
then we do,
X times 3.
which gives us,
3x.
then we do,
3 times x.
which gives us,
3x.
then we do,
3 times 3.
which gives us,
9.
and then are we done?
No.
What do we do?
X squared.
Yes,
Plus 9x. I mean 6x.
Yes.
Plus 9.
yes. We combine our like terms, 3x and 3x combine to give us 6x. X squared plus 6x plus 9.
Alright.
That is not as much as
No, it's not. So you just need to recognize that that's what's going on. Where these are going to get trickier is when you have negatives involved. Notice that is this negative here? But just remember that subtraction means adding a negative. So there, we had to make sure that when we multiplied, for example, 4 and 3, we're actually multiplying 4 and negative 3. We get negative 12. So be careful with your negative signs.
So,
Oh yeah, Captain.
what if it's like x plus 3 in parentheses cubed?
Yeah, what if it's cubed?
So
then-
it'll be x times x times x?
Then we, because if it were cubed, that would be like this, right?
Oh yeah. What was that?
We can't do first, outer, inner, last on that. I think the easiest thing to do would be to multiply the first two together, and then take this and multiply it by x plus 3 again.
Really?
I think if they asked you to cube it, that would be the easiest way to do it, yes.
If they asked us to what?
Cube it.
Oh, okay, so
Right?
times 3.
If we're raised to the third power, yeah. So I think the easiest thing would be to do that. Then we'd have to do x times x squared, x times 6x, x times 9, then 3 times x squared, 3 times 6x, 3 times 9
Alright.
is what we'd have to do.
So
But
x cubed.
it'd be x cubed,
X squared
x cubed
plus 3x squared
plus 3x squared,
plus 6x squared
yep,
plus 18.
nope,
No, plus 9x.
yep,
Then plus 18
3x squared plus 18x
plus 26.
plus 27, yeah, then we'd have to combine our like terms.
That is a lot.
That would be a lot. This is not something you're going to be asked to do. Cubing these at this point is not something you're going to be asked to do. Please take the sweatshirt off the desk.
How about later on in the year?
I don't think so. I don't think the book introduces that at all.
Okay.
All right?
Yeah.
Okay. Yes. Other questions from the homework that you want to go over, especially ones that cover lessons. We did 48 together, didn't we?
Yeah, we did.
Yeah, we did. Okay, especially ones that cover 49, 50, and 51. So we did 19 and 20. Those are on 49.
I wanted to go to 12, but that's 40.
Number 12, that's fine. Number 12, this is one of these two-step equations. They say if x plus 9 equals 3, find the value of negative x squared plus 4. So what are they asking for here?
They're asking me to figure. Actually, no, I don't have to do this.
Yeah, so what do we do first?
X plus 9 equals 3, so minus 9 on both sides.
Yep.
And then x equals
Negative 6.
negative x squared plus 4.
Negative x squared plus 4.
So that means negative parentheses negative 6, both parentheses squared
Yes?
plus 4.
Yes.
And negative 36
Plus 4.
plus 4.
Negative 32.
Yes. Make sure you're reading carefully so you know what they're asking. If you just solve that first part, that's great. It is true that in this problem, x equals negative 6. But that's not what they're asking for. We're asking if that's the case, then what is this equal? This is what they're asking about. Negative x squared plus 4.
Yeah, we do 14 or 15.
14 or 15. 14 and 15, yes. So these ones come from lesson 51. I actually want to, let's talk about lesson 51 together first before we do that. All right, so we're actually going to have to talk about 50 and 51. Are there any questions before we go over 14 and 15? Are there any questions from anything up to lesson 49 before we go over 50 and 51? Because I want to do 50 and 51 all together.
Hey, Mr. O.
Yeah.
So wait, for the homework, we have to do 48 too, or just 49, 50, 51?
48, I think I already checked.
Oh, yeah. Okay. Just make it.
Okay, and for the ones, listen, for the ones that were due while I was out, please get them to me. If you don't get them to me, I'll assume that there's some good reason for it. I won't take off for it, but you won't get credit for it.
Wait, I lost 49.
So
But I have 50 and 48 and 51.
Mine's in the trash.
Okay.
Like, will you like take off points for that or you?
What did I just say?
I don't know.
Okay.
I know that. This is-
It only affects a little. Yeah. All right. So listen, you can also turn them in on Jupyter Grades. Okay. Are there any questions from the homework up to and including on problems up to and including lesson 49? Not the ones from 50.
29.
Which one?
29.
29. 29. Okay. Find the area of the rectangle in square inches. Okay. Yeah, that one's really annoying. Well, it's actually not that annoying. Notice they tell you some useful information here. The little apostrophe after that means feet. So what's the height of that rectangle, or the width?
6.
What?
Is it number 29?
Yes, problem number 29.
Oh.
I think you're looking at 28.
Yeah.
What's the other one? 32.
What? That's not what I'm looking at.
That's 29.
Oh, 51.
Oh, I'm on problem set.
I'm sorry, I'm on the wrong page.
Wait, no.
Okay. This one you just converted. What?
I also don't understand that.
Okay, this is from the previous lesson. They asked you for square inches. So, what's the problem here?
6.
1 foot is 12 inches. Now we've got inches and inches. We just multiply the area.
Oh.
Okay.
I got the other one wrong.
Okay, but 29 from problem set 51 on page 211. Finding the area of this figure. Dimensions are in what unit? Inches. All right. Do we have a formula for this kind of funky shape?
Oh.
No.
No. Okay. What things is it made out of that we do have formulas for?
Semicircle and rectangle.
Okay, we've got a rectangle there, and we've got a semicircle involved, right? If we imagine a dotted line here, it's easy to see the rectangle and the semicircle. So let's figure out the areas of those. Okay, what's the area of this rectangle?
Well,
What's the area of this rectangle? 24 what? 24 square inches. How did you get 24 square inches?
He squared it.
No. How did we find the area of the rectangle?
6 times 4.
Yeah, where'd you get the 4 from?
Because the radius of the circle is 2, and since the circle takes up the whole thing of the width, I think it's 4.
Right, so notice that to find this dimension of the rectangle, we have to look at the radius of this semicircle here, which is 2. So if it's 2 going up and 2 going down, it means it's 4. All right, so the area of the rectangle, say it again?
I'll bet I asked for that. I mean, I think we'd have to just develop it.
Well, would you rather miss out on this or miss out on 50 and 51? Okay, then go. Go now. Okay, what about the area of the semicircle? What's the area of this? How do we find the area of a semicircle? Right, it's just a circle. See, this is what happens when you don't sleep. But seriously, get enough sleep. All right,
I did.
Mr. Oh, if you need a babysitter, I'm always here.
yeah?
No, no.
Bring the kid in, you can just sit there in the back, just holding him.
You can say.
Yeah, I like
All right, pi r squared over 2. It's nice when they sleep. It is very nice. So what's the area of this semicircle? The radius is what? 2, so the area is? Yeah, 2 pi. So it's pi 2 squared over 2, or 4 pi over 2, or 2 pi what?
Inches squared.
Yeah, square inches. Now, we've got the area of the rectangle, we've got the area of the semicircle. What do we do with this information?
24 minus 2 pi.
Why did you subtract? Why did you subtract?
We add, don't subtract.
Why do we add?
Because we were trying to get the
The area of
so you
this
multiply.
thing.
So you
But
Oh,
you,
without it.
You take out the 2, like, cause it's not, you're not finding it.
Right. This weird funky shape that they gave us is like a rectangle, like a rectangular brownie that somebody took a big bite out of. Arr.
Ashton.
One of my professors in college, he was from Europe, and he always loved to talk about brownies and how they don't have brownies in Europe.
That's special.
And this is one of the things that he liked about living in the US. Anyway, so, right, to find the area of the whole thing, we have to subtract those 2 pi square inches. Because we had a rectangle, it's like we had a rectangle and then somebody took a bite out of it. Yes?
Yeah.
Other questions about this? Okay, turn to page 200. We're going to go over lessons 50 and 51 together. I know I wasn't here for this, but let's talk about this because this is a different topic. It's sort of a different thing from a lot of the stuff that we've been doing. This is more on the geometry side of things.
Geometry?
We have a question. Why are they?
Exactly, bro.
All right.
I don't get it.
They're boxes that are bigger, so you have more room to do work.
Yeah, normally for the test we have bigger boxes, and they've just been in short supply this year. I just need to make some.
How long is that short?
I'm sorry?
How long is it short?
Just because you have to make copies of them to have them. And just people haven't been doing that, and I haven't been doing it either.
Well,
So there just haven't been a lot of it.
how we just.
It's all right, lesson 50, page 200. The first thing that's mentioned here, when we talk about the degrees of polynomials. Polynomials, we have multiple terms, algebraic terms added together. The degree of a polynomial is the highest exponent on a variable. This is something from, I think, lesson 48. This is not new. Yes, it's familiar to you all?
Yeah.
Okay. So if, for example, we have, if you look there on the top of page 201, you see x cubed plus xy plus m. That's what degree?
3rd degree.
3rd degree. 2x plus 4y is?
1st degree.
And 2x is?
1st degree.
Okay, next one down, x to the 4th minus 3x squared plus 2 equals 0.
4th degree.
4th degree. Now notice the difference here between what was above, those first 3, and these next 3. What do we have in the second set that we didn't have before?
A number with a variable and an exponent. And a subtraction.
Well, we could have had subtraction up above.
And an equal sign.
The equal sign with something on the other side. So what kind of things do we now have the second set there? Please keep this on your desk.
Why are you playing?
Dude, why are you playing like that, bro? It's not even fun.
So what are these things now? Rather than being polynomial expressions, now we have a special name for them because they have this equal sign in it. They are,
4th degree.
what do we call algebraic things that have an equal sign with stuff on either side of it? Equations. These are polynomial equations, which are just equations that involve polynomials. So for example, y equals 2x plus 4, or x to the 4th minus 3x squared plus 2 equals 0. These are polynomial equations. Yes? Notice that this one involves
Yeah.
a polynomial. What degree is this one? What degree is this one here?
4th.
This is 4th degree. This one is?
3rd.
What degree is this one? What's the highest exponent that we have on a variable?
Oh, 1.
1. It's a 1st degree.
Oh, so the degree goes by exponent.
Right, the degree is the highest exponent on a variable.
Okay.
That's how you determine the degree. Okay, this is just terminology right now.
Wait, why are there?
So sometimes we have exponents.
It's math.
Algebra, bro.
You're gonna put that on the test. That wasn't even in the book.
Who do you think's gonna teach us?
This is on page
In my
201.
book.
Who do you think's gonna teach us next?
This is material from page 201. All right, now,
So back them already.
when we have algebraic equations,
Yeah.
and especially when we have things of this kind of format, y equals 2x plus 4, we have some tools that will help us out. Now, what's the problem with, okay, if I ask you to solve this, this would be really annoying to solve. It is theoretically possible. But this one, what would you do if I asked you to solve this one? Y equals 2x plus 4.
It's already solved. Are we solving for y?
Okay, there's a good question to ask. Are we solving for y? If we're solving for y, then yes, it's already solved. But can we get it any more straightforward than that? Like x equal, what does x equal?
We can subtract by 4.
We can make x
And then
equal 1,
it's gonna
2,
be
3.
it's gonna be y minus 4 equals 2x.
How many solutions, maybe, let me ask it a different way. How many solutions are there to this equation?
Like 4.
No, there's like a lot.
A lot. An infinite number of solutions.
Oh.
Why? What are there two of in this that usually in our equations we have one of? Two variables. When there's one variable, when there's only one thing changing, we can get it by itself and figure out what it equals. When we have two variables, they're both changing. So how do we figure out any useful information from this? This is where this thing comes in handy. We said that there are an infinite number of solutions to this first equation, y equals 2x plus 4. Yes?
Yeah.
But not any two numbers. But what's an example of something that would solve this equation here? Y equals 2x plus 4.
You can make 1.
You made what one?
X.
Okay, if x is 1, then y is equal to 6. This makes this true. This solves this equation. It works out. What if we have x equals 2 and y equals 6? Does that work? No, because what's 2 times 2 plus 4 is 8, but we said y is 6. Okay, x equals 1 and y equals 6, that works. X equals 2 and y equals 6 doesn't work. So how do we understand which sets of numbers, which combinations of... Well, graph usually, we talk about the graph of a particular equation, but what do you call this thing that I'm drawing here without any equations on it so far? The name is on page 201.
Coordinate plane.
Coordinate plane.
Yeah, so the Cartesian plane. The Cartesian plane. Notice, what I've done here is I've combined two number lines that are at right angles to each other. Normally when we've got a number line, it's just horizontal. And it goes forever negative and forever positive, yes?
Wait, I forgot. How did you get x equals 1 and y equals 6?
Well, we just say, we can talk about that in a minute.
Alright.
We'll come back to that. We've got one number line for x. The way to remember that x is this one is that it goes across, and x looks like a cross. Get it? Okay. And then y has another number line where it goes positive up and negative down. Yes? Okay. Each one of these lines represents a particular value for those things, just like any other number line.
Why did you make it so big?
Why not?
Oh wow, this is.
So you guys can see better.
So like I usually don't do it like 3.
Okay.
I like 5.
All right, notice it goes on forever in all four directions. When we use this, this lets us get a visual idea. Oh shoot, I wrote these in the wrong place.
I always get that sometimes. Wow.
I love to.
What?
In the future, you can feel free to speak up about that kind of stuff, because that's the problem. All right, each point, anywhere on this plane, it's a flat surface, represents a combination of x and y. So this one here, for example, let's do this guy here. That point there represents what combination of x and y?
4, 2, x,
Two.
y.
Yeah.
Yeah, x equals
Let me-
Mr. I think you skipped a thing
Oh,
on the x, on the y-axis and the negatives.
I did it again. Look at that.
What do you mean skip it?
It's okay, Mr.
Skip it
Owen, you're
down.
human.
It's okay, you'll get it next time.
Uh-huh.
This is like my
Just
test practice
happen.
here. I'm gonna get half bounce back to
Matthew.
All right, thank you for pointing that out. All right, so this point here gives us two pieces of information. It tells us x is 3,
Oh.
and it tells us y is what?
-4. Wait, no.
No, 4.
Positive 4. The way that we usually write this is instead of writing x equals 3 and y equals 4, we write it like this, 3, 4. It's always going to go x first and then y. It's in alphabetical order. So the x value is 3 and y is 4. What about this point? What about this point here? What are the coordinates of that point?
5, -1.
5, negative.
Yeah.
What about this guy here? What are the coordinates of that?
-7.
Looks like -6.
Yeah, I think it's -6. It's not perfectly straight. -6,
10
I think it's more like 9.
or 8, yeah.
-6, 9. Because x is -6, here we're to the left, and y is 9. And then this guy here, right, it's going to be 2 negatives. X is what?
-1,
-6, comma, -1.
-6, -1. Yes.
That's what I said, that's why.
Every single point on this represents a particular combination of an x value and a y value. Man, we're running out of time.
We are?
But that's okay, actually, because this stuff isn't on tomorrow's test, so we can spend more time talking about this on Friday.
Right.
All right.
Good.
Now. All right, that's 50. That's 50 there. This thing here is called an ordered pair. What's this called?
Ordered
An
pair.
ordered pair. Why? Because it's a pair of numbers,
In a certain order.
and they're in a particular order. Which one always comes first?
X,
Please listen. You can continue the conversation later. Which one always comes first?
X,
X. Which one always comes second?
Y.
Thank you. All right, it's an ordered pair. It's a pair in a particular order. Now, in lesson 51, we start to do some things with this, and that's where we can see y equals 2x plus 4. We'll talk about 51 on Friday. Right now, we have about 3 minutes. Are there any last questions up to and including lesson 48 that you want to go over? Anything from those lessons? You want to take a look back on those pages up to and including page 194 or so that you want to go over that you don't feel 100% comfortable with? You can also come after school today.
Oh, really?
Yes, I'll be available after school today. I know usually it's Tuesdays, but since I'm here today, I'll do it today, right here at 2:45.
There's no player.
Listen, I'll be here 2:45 to 3:45. Drop in for as little or as much time as you want. But please, if you have questions about the test tomorrow, don't just hope that these kind of things are going to go away.
Can you do
Yes.
number,
You make this Friday.
either number 5 or 6
Yeah,
from
what was that?
concept 48?
From problem set 48, so we're on page 195, 5 and 6.
Yes.
Yeah, so here, for number 5, what percent, let me get my red marker.
You always have a red marker?
No, I just got them. We did a Secret Santa with one of my classes. One of my students gave me a bunch of colored dry erase markers. I was thrilled. This is what it's like being a grown-up. All right. Page 195, we're on lesson 48. Numbers 5 and 6. So let's do these together. What percent of 160 is 88? Anytime we say what percent, what decimal, what fraction, we're always going to use a what? A variable. Yes. What percent of 160 is what? 88. Notice what percent of 160 is 88? A little bit easier. You can actually skip a step. If you want to, when it says what percent, we just set it up over 100.
Wait, it's gonna be on the
Yeah, this is problem set 48.
Also, it's gonna not be over 100.
Your answer will be a percent. So, like if it's 12%, then x is 12,
I have
right?
so many problems with percentages.
There aren't that many, it's from a recent lesson. All right, so x over 100 times 160 over 1 equals 88 over 1. Notice I just wrote these as fractions to make my life easier. So we got 160x over 100. I just multiplied across the top and across the bottom, equals 88 over 1. Now what do I do? Before I cross multiply,
Not. Yeah,
simplify. What can I simplify here? Yeah, first of all, the zeros. What else? Yeah, 8x over 5 equals 88 over 1. Now what do I do?
now you cut.
Now we cross multiply. If we want to, there's an easier thing we can do here. Notice 8x is 88. So what's x there?
Huh?
So,
8x, so 11x.
yeah, so we multiply by 11 to go from the one to the other.
And then you multiply the bottom by 11.
Yeah, and we're going to get what on the bottom?
88 over 55.
Yeah, we're going to get 88. What did I do here? Sorry about that. Totally lost my train of thought.
I like the salty. I hate the salty, but you do like this.
You're
How
weird.
salty you like that?
You love those.
Oh, no. Listen. Here's what you do. Sorry.
Those are annoying.
What we actually want to do is, let's make these be,
And then if you do it the wrong way, it won't come out.
I mean, so you can do 8x equals, 8x equals what? 8x equals what?
8x equals 8x.
Equals
8x equals.
Oh,
80.
or
88 times
5.
5. All right. Then we do what?
5 by
5 by 8. Okay. 88. Listen, you could multiply here first 88 times 5 and then divide by 8, but easier is if we divide out the 8 first. 88 divided by 8 is what?
11.
11 times 5 is, what percent of 160 is 88? When it says what percent, you don't have to, but it's a good idea to set that up as a fraction over 100. Then we just combine these two fractions here, and we cross multiply to find x.
Yes, sir, Kevin, sir.
I'm sorry?
Say yes, sir.
We're gonna call you Kevin.
That's what I thought. All right, goodbye. I'll be here this afternoon. Thank you all very much. Yes.